Assalamu alaikum, dear student. This is Muhammad Mahbub Alam, lecturer in chemistry, English medium day shift, Rajaguttara Model College. Today, I would like to deliver a very important lecture on organic chemistry. This is my sixth lecture of the chapter. For the first time, I would like to say something in my lecture about phenol. Okay, what is the preparation process of phenol? There are two processes to produce phenol, one is cumene phenol process, another is Dow process. So to prepare phenol, there are two processes. First one is cumene phenol process and second one is Dow process. So what is cumene phenol process? In cumene phenol process, benzene, for the first time, benzene react with propene. Okay, benzene react with propene to produce isopropyl benzene. For the first time, in cumene phenol process, the first target to produce cumene, which one is called isopropyl benzene. This can be produced by treating benzene with propene. By treating benzene with propene, cumene can be produced. After the production of cumene, in presence of cobalt as catalyst at 130 atmosphere pressure, in presence of oxygen, cumene can be heated. Then this cumene will be converted to cumene hydroperoxide. This product is called cumene hydroperoxide. So for the first time, you have to produce here isopropyl benzene or cumene from benzene and propene, and after this, by the oxidation of oxygen in presence of cobalt as catalyst at 130 atmosphere pressure, this cumene will be converted to cumene hydroperoxide. After the production of cumene hydroperoxide, in presence of slight amount of acid, for example sulfuric acid can be, this compound will be hydrolyzed, and by this way they produce the product phenol, which one is our target product. At the same time, propanol can be produced here as a byproduct. So this is the process to produce phenol, which one is called phenol process, cumene phenol process. Now the Dow process. Okay, this is very easy and simple process. In this process, benzene is treated with chlorine in presence of dust of iron. Okay, benzene is treated with chlorine in presence of dust of iron. By this way, they produce chlorobenzene, and then 10% sodium hydroxide is used in that case at 150 atmosphere and 400 degrees Celsius temperature. When this chlorobenzene treated with sodium hydroxide, 10% sodium hydroxide is basically used here, then this chlorobenzene will be converted to sodium phenate, and after that you have to add here hydrochloric acid at 182 degrees Celsius temperature. Then this sodium phenoxide will be converted to phenol. So by this way you will be able to get phenol. Okay, so there are two processes. One is cumene phenol process, another is Dow process. By using these two processes, we are able to prepare phenol easily. So dear student, now about acidic property of phenol. If you want to know about acidic property of phenol, you have to consider for the first time the resonance structure of the phenol. This is the resonance structure of the phenol. I have already discussed in my previous lecture the resonance structure of phenol or wedge. So from this resonance structure, this is clear from structure 2, structure 3 and structure 4. This is clear to you that all the structure contain oxygen atom which has positive charge. Okay, as oxygen atom has positive charge, at the same time oxygen atom can act as a good electronegative element. So as it has a latency of electron, it has a shortage of electron, deficiency of electron, so at the same time it can act as a good electronegative element. So it should attract the electron in between the two atom, oxygen and hydrogen atom. It should attract the electron towards itself. By this way, the bond which will be weaker. So when phenol, when you dissolve phenol in water solution, then it will easily give proton from this in this solution of water. Okay, something that can be produced, that can be donate proton in water solution is called acidic in nature. Okay, so as phenol, when it is dissolved in water, as it can easily donate proton, So I can say phenol has also acidic property. So dear student, now identification of phenol. There are three processes to identify phenol. For the first time, bromine water test, second ferric chloride test, and third one is Leverman test. In bromine water test, if you take the solution of this compound in a test tube and add bromine water dropwise, then we will get yellowish precipitation of 2,4,6 tribromophenol. Okay, so from the yellowish precipitation of this compound, you will be sure of that there must presence this compound. Okay, now ferric chloride test. If you take a test tube having this compound, if you add ferric chloride, what is the name of this compound? Ferric chloride. Okay, if you add ferric chloride dropwise in this solution that contain this compound, then they are produced diferric hexafinate. This compound will be produced which has violet precipitation. Okay, so they are produced a violet PPT or precipitation. From this precipitation, you will be sure of that in this test tube there must presence phenol. Now the Leverman test. This is very important test. Okay, in this test, what happens? Phenol and solid sodium nitrate. Phenol and solid sodium nitrate are taken in a test tube for the first time. A few drops of concentrated sulfuric acid is added to it. Then a few drops of concentrated sulfuric acid is added to this solution. Okay, so you have to take a test tube, and if you take for the first time, you have to take the solution of phenol, and later you have to add sodium nitrate. After added sodium nitrate, you have to add sulfuric acid dropwise. Then they produce this product, whose product name is para-nitrosophenol. The solution will be blue in color. Okay, then the mixture is heated. If you heated this mixture, then the solution turns blue or green. Okay, when sodium nitrate in addition with sulfuric acid is added in this solution, then they produce para-nitrosophenol which has blue in color. Okay, so blue or green color, the solution color will be turned into blue or green color. Then if water is added to the solution further, if you add here water for the further time, then they produce indophenol. Okay, the name of this compound is indophenol, which one has red color. Okay, so the blue color solution will be turned into red color solution when you add water in this blue colored solution. Okay, later on adding excess sodium hydroxide to the red solution, when you add sodium hydroxide in this red colored solution, again it turns green or blue again. Okay, when you add excess amount of sodium hydroxide in this red colored solution, then they produce indophenol sodium salt which has blue color. So again blue color will be appear. So for the first time, the color of the solution was blue. When you add here water, then they produce indophenol which has red color, and when you add here excess amount of sodium hydroxide, then they produce indophenol sodium hydroxide which has blue in color. So again blue color appear here. If this happens, then you will be sure of that in that test tube there must presence phenol. So these are the Leverman test. Okay, so dear students, now I would like to say something about amine. For the first time, you have to know what is amine. Okay, amine is basically organic compound that contain NH2 as a functional group. Okay, you can prepare amine easily. Just to consider the structure of ammonia. Okay, in the structure of ammonia, you have seen that nitrogen atom is attached with a 3 hydrogen atom, right? If you replace one of hydrogen by a alkyl group, okay, you know this here R is a alkyl group, If you replace this R by this hydrogen atom by a R, then you will get 1 degree amine. Okay, so the compound that basically contain NH2 as a functional group is basically amine. So this is clear to you. There is a functional group NH2, and if you just here replace this hydrogen by R, so you get 1 degree amine. If you replace another hydrogen atom of this 1 degree amine by another alkyl group, then you will get 2 degree amine. At the same time, if you replace another hydrogen atom of 2 degree amine by another alkyl group, then you will get 3 degree amine. So basically, in case of first or 1 degree amine, the functional group is NH2. In case of 2 degree amine, the functional group is NH. In case of 3 degree amine, the functional group is only nitrogen atom. So the amine that contain one alkyl group is called 1 degree amine. The amine that contain 2 alkyl group attached with it, 2 degree amine. The amine that where 3 alkyl group is attached with the nitrogen atom is called 3 degree amine. These are aliphatic amine. Okay, all of them are aliphatic amine. Now these are aromatic amine, the amine that must contain an aryl group. Okay, it must contain an aryl group. This is here basically an aryl group. You know, the name of the group is phenol group. Okay, so this type of compound is called aromatic amine. It has another name. The name basically it is also called aniline. Okay, and this is 1 degree amine. This is 1 degree aromatic amine, and here if you replace one hydrogen by another alkyl group, then it will be converted to 2 degree amine, 2 degree aromatic amine. If you replace the rest of the hydrogen atom by another alkyl group, then it will be converted to 3 degree amine. So these are basically the 1 degree, 2 degree, 3 degree aliphatic amine, at the same time 1 degree, 2 degree, 3 degree aromatic amine. Now I would like to say something about the preparation of amine. What is basically the preparation? There are three process. There are number of processes to prepare amine. You know, for the first time, if you want to prepare 1 degree, 2 degree, and 3 degree, you have to react in between ammonia and alkyl halide. If you want to prepare 1 degree, 2 degree, and 3 degree amine. Okay, if you treat methyl iodide just with ammonia, then you will get 1 degree amine. Okay, this is basically one kind of substitution reaction. Here hydrogen atom will be replaced by NH2. By this way, CH3 NH2 will be formed, and this type of compound is basically called 1 degree amine. At the same time, if you treat methyl iodide with the 1 degree amine, okay, 1 degree amine, then another hydrogen atom of nitrogen and H2 group, one hydrogen will be replaced by this CH3. Okay, so by this way you will be able to get CH3 NHCH3, which one is called 2 degree amine. At the same time, if you react methyl iodide with 2 degree amine, 2 degree amine has a one hydrogen atom. Okay, so this hydrogen atom will be replaced by another methyl group. If it is happened, then you will get 3 degree amine. Okay, this is clear to you that there are only methyl groups. So this is 1 degree, and there are 2 methyl group attached with the nitrogen atom. So this is 2 degree amine, and there are 3 methyl group attached with this nitrogen atom. So this is 3 degree amine. So by this way you can prepare 1 degree, 2 degree, 3 degree. So to prepare 1 degree, 2 degree, 3 degree amine, you have to make sure the reaction in between ammonia or alkyl halide or amine and alkyl halide. Now from the isonitrile and nitrile compound, this is also possible to produce 1 degree amine and 2 degree amine. If you reduced nitrile compound with a reducing agent, say for example lithium aluminum hydride, if you reduced this compound with a lithium aluminum hydride, which one is called reducing agent, then it will reduce this portion. Okay, C and portion will be reduced by this reducing agent and will be converted to C will be converted to CH2 and N will be converted to NH2. By this way CH3CN will be converted to CH3CH2 NH2 group. Okay, the name of this compound is 1 degree amine. Okay, 1 degree amine. At the same time, if you reduced isocyanate compound, isonitrile or isocyanate compound, for example this is methyl isocyanate compound, by using this reducing agent, then you will also get CH3, NH, this nitrogen will be converted to NH and C will be converted to CH3. By this way, you will be able to get this type of compound, which compound is known as 2-degree amine. So by using nitrile or isonitrile process, this is possible to prepare 1-degree and 2-degree amine. Now another process, Hopman degradation process, right? Hopman degradation process. So Hopman degradation process, this is very important process. This is basically a process where a carbon will be eliminated from this compound, and the reaction of amide with bromine in presence of alkali. When this reaction happen, they are produced amine. Okay, 1-degree amine normally you can produce by this way. The point that must be noted in that case, CO group will be eliminated from here. For this reason, this the name of the reaction is Hopman degradation. There happen the degradation of carbonyl compound, carbonyl group basically happen here. Okay, so when you make sure the reaction of amide with a bromine at the same time strong alkali, potassium hydroxide or sodium hydroxide, then CO group will be eliminated, will be degraded from this compound, and by this way amide will be converted to amine. In this way you will be able to prepare 1-degree amine. Now the reduction of nitrile alkane. Okay, if you reduce the nitrile alkane, especially NO2 portion, okay, if you reduce this NO2 by using a reducing agent, then NO2 will be converted to NH2. Okay, so when you convert NO2 into NH2, then you will be able to produce amine. Okay, so here stannum and HCl can act as a reducing agent. You know, this is the reaction when stannum and HCl react each with other. They produce stannum chloride, at the same time nascent hydrogen atom or active hydrogen atom. So this you know very well, the reducing agent can supply nascent hydrogen atom. Okay, so by using this nascent hydrogen atom, NO2 group will be converted to NH2. By this way you will be able to get here 1-degree amine. So these are the process to produce basically amine. For the first time, preparation of amine, 1-degree, 2-degree, 3-degree amine from the reaction of ammonia and alkyl halide, at the same time alkyl halide and amine. You will be able to prepare 1-degree, 2-degree, 3-degree amine. Okay, and secondly, 1-degree and 2-degree amine can be prepared from the reaction of nitrile and isonitrile compound, and finally the third process is Hopman degradation process, and last one is reduction of nitrile alkane. Okay, there are a number of processes basically, but among them these are very important processes. That's why I discuss these processes. So dear student, now basicity of amine. This is very important properties of amine. For the first time, if you want to know about the basicity of amine, you have to know the orbital structure of amine. The nitrogen atom in amine are sp3 hybridized, and two of the sp3 hybridized are used to form sigma bond with the hydrogen atom. At the same time, another sp3 hybridized are attached to the alkyl group, and another sp3 hybridized orbital contain a lone pair of electrons. So from the orbital structure of the amine of nitrogen atom, this is clear to us that nitrogen atom contain a lone pair of electrons. According to the concept of acid base Lewis concept, any atom of any compound, if it contain a lone pair of electron, if it receive a proton by using this lone pair of electron, this type of compound are basic in nature. Okay, they have basic character. Now I would like to consider the all the compound that I have written on the board. I would like to analyze the basicity of the compound that I have written on the board. For the first time, ammonia, both ammonia 1 degree, 1 degree, 2 degree, 3 degree, and aniline, all of them contain a lone pair of electron, as they contain a nitrogen atom. So as they all contain a lone pair of electron, they all should receive a proton. Okay, as they all receive protons, so you can easily say they all have basic character, right? Now I would like to determine the basicity order, which one has greater basicity. Okay, I have to determine it. In case of ammonia, what you see, there are no any electron donating group, alkyl group are attached with this nitrogen, with the nitrogen atom of ammonia. Nitrogen atom is attached with the 3 hydrogen atom in case of ammonia, right? In case of 1 degree amine, these nitrogen atoms this nitrogen atom is attached with a single alkyl group. In case of 2 degree, this is attached with a 2 alkyl group. At the same time, in case of 3 degree, it is attached with the 3 alkyl group. Each of the alkyl group here can act as a electron donating group. So positive induction effect is possible in that case. Now the point that you must have to notice in that case, the greater the electron density around the nucleus, the greater the chance to receive proton. Okay, the greater the chance to proton receive, the greater the basic character of that compound. Okay, in case of, if you consider the 2 examples, as it doesn't contain any alkyl group, so electron density in that case will be comparatively lower than that case. There is the alkyl group you have seen in the board, that in case of 1 degree amine, so it can supply electron density according to the concept of positive induction effect. So the electron density in that case will be greater comparatively than this ammonia. At the same time, if you analyze, if you consider that then 1 degree and 2 degree, the nitrogen atom comparatively have greater electron density than the nitrogen atom of 1 degree, as they contain 2 alkyl group. Okay. At the same time, in case of 3 degree amine, as they contain 3 alkyl group, so as they contain 3 alkyl group, so electron density around the nitrogen atom will be greater in that case. Okay. Now the basicity, which one will have more basic character? Just you consider the 2 example. In between 2 example, 1 degree amine must have greater electron density in nitrogen atom, so it has more basic character. If you analyze 1 degree and 2 degree, then 2 degree amine will have more basic character. If you analyze 2 degree and 3 degree, what will happen? Though the nitrogen atom has a greater electron density towards around itself, but it is attached, as it is attached with the 3 alkyl group. Alkyl group are called bulky group. They are bulky group. As they are bulky group, so there is a chance to have repulsion in that case. So this is very important factor, repulsion between the bulky group. Another point is to attack proton. There causes a effect, which effect is called steric effect or steric hindrance. As 3 bulky group are attached with the nitrogen atom to attack nitrogen atom by this proton, there is a trouble. Okay, it cannot attack to the nitrogen atom as they are present 3 bulky group around the nitrogen atom. So here basically act steric hindrance type problem, and that's why proton cannot easily attack to this nitrogen atom, though this nitrogen atom contain a greater electron density among all 1 degree, 2 degree and 3 degree, and that's why the basic character in that compound will be reduced. At the same time, in case of aniline, what happened? Nitrogen atom has a lone pair electron, so to basic, in case of basic character, this lone pair electron is very important. Okay, so in case of aniline, the lone pair of electron can receive a proton, this is fine, but at the same time there is a chance to participate these lone pair of electron in the resonance structure of the aniline. The lone pair of electron can participate in the delocalization of the pi bonding electron. So if it participates in that case, so it has there has a very small chance to receive in that case. So as it already participated in the resonance or delocalization, so there is a little bit chance to receive proton by this nitrogen atom. So the basicity of this compound will be very small. Okay, so from this concept we are able to now understand that these are basically the pKb value. The greater the pKb value, the lower the basicity of the compound. The pKb value order, this is clear to us that the pKb value of the compound has 2 degree, lowest pKb value is 2 degree, then 1 degree, then 3 degree, then ammonia, and then aniline. the lowest the pKb value, the highest the basic character. At the same time, from this concept, this is also clear to us. So if you analyze all the 5 compounds, then you will get the basic character. Among all the compound, 2 degree amine has 2 degree amine is more basic than 1 degree. 1 degree is more basic than 3 degree, and 3 degree is more basic than ammonia, and ammonia is more basic than aniline. So the basicity order is basically 2 degree, 1 degree, 3 degree, ammonia and aniline. So dear student, now identification of 1 degree, 2 degree and 3 degree amine you can identify by using nitrous acid. Okay, in case of 1 degree amine, if you use nitrous acid, so nitrous acid will react with this 1 degree amine and produce methanol, nitrogen and water. Okay, the presence of nitrogen, there is a bubble of nitrogen will be produced. In that case, the presence of nitrogen gas, the production of nitrogen gas will confirm that the solution must contain 1 degree amine. In case of 2 degree amine, if you use here nitrous acid, then they are produced yellow colored oily nitrous compound. So yellow colored nitrous compound precipitation will be produced. In that case, from these you will be confirmed that there must presence 2 degree amine. In case of 3 degree amine, they are produced when 3 degree amine is react with nitrous acid, they are produced water soluble trimethyl ammonium nitrate salt. The salt that is soluble in water, the name of the compound is water soluble trimethyl ammonium nitrate salt. So from here it will be clear to you that there presents 3 degree amine. So dear student, at the end of the class you will be able to know about the phenol details, preparation of phenol, acidic character of phenol, identification of phenol, classification of amine, preparation of amine, basicity of different types of amine, and identification of 1 degree, 2 degree and 3 degree amine. Okay, thank you.